When recording very small or very large numbers, oftentimes it would be recorded in something called scientific notation. You may be familiar or know scientific notation as exponential notation. This should be something you've already seen before in one of your math classes. But this little short video just goes over how we write things from standard notation to scientific and notation and back and forth. So usually you don't have to write everything in scientific notation, although it is quite easy to write numbers that like from 100 and greater, or from 1/10 less. It's not hard to write those numbers in scientific notation, but it's not always required either. So the general form of scientific notation is written right here. So you're going to have a number here that's at the front, and this is called your coefficient. Now the coefficient, there's a couple things about the coefficient here. The coefficient has to be between numbers 1 and 10. Really, it's 1 and 9. It's never a 10. I guess so, between 1 and 10, so less than 10. And it has, and that coefficient, when we talked about significant figures in the previous video, the number of digits in your coefficient is equivalent or equal to the number of significant figures. So a coefficient might look like 2.54, or it could be 9.1, or it could be a 3. So it could be in a variety of forms. But notice that the number here is always between 1 and 10. So I would never have a coefficient that was 25.4. So this would be an incorrect way to write a coefficient. Then when we take the coefficient, we multiply, it will say times, and then it has a 10, and then you're going to have 10 to a power here. That power is called an exponent, and basically scientific notation or exponential notation is rewriting a number based on a power of 10. Now that exponent can be a positive or a negative integer, so it's a whole number. So we could see something like it could be times 10 to the square, 2. The 2 is the exponent. It could be times 10 to the negative 6. Times 10 to the, 4, right? So any of those would be acceptable ways to write the exponent. So when we're talking about scientific notation, these examples are just examples of what we might expect to see if we saw a number that was written in scientific notation. Now, here are two examples. So if right here, are two examples that we'll go through on how to write a number from standard notation to scientific notation. But before I do that, I just want you to understand. So mathematically, all we're saying here, we're taking the number 2.54 and we're multiplying it by 10 squared. Now 10 squared is just saying 10 times 10. So basically what this number is saying is 2.54 times 100, and that would equal my number. Now negative exponents, if you recall, when you have negative exponents, to make them positive, we put them in the denominator. So this is really, it's saying 9.1 divided by 10 to the 6th, where 10 to the 6th would just be 10 times 10 times 10 times 10 times 10, like 1, 2, 3, 4, 5 times 10, 6 tenths. Now, luckily, we do not have to think it through this way every time. Instead, since it's powers of 10, we just move the decimal. So come back again over to the notes and let's look at these two examples. So here's a large number, and we call the zeros that come after the 2 and the 5, those are called trailing zeros. Now to write this in scientific notation, you start where the decimal would be, and you count over how many times it takes you to move the decimal so that it makes the coefficient between the numbers 1 and 10. Basically, the decimal place will have to be directly after the first non-zero digit, or I think of the decimal as being in the second place, so you'll have a number, then a digit. Now when I move the 0 in this example, I had to move it 1, 2, 3, 4, 5, 6, 7 times. So then my exponent is a positive 7. Large numbers will always have positive exponents because what it means is this is a very large number, so it's 2.5 times 10 to the 7th power, or times 10 7 times. Now, on the other hand, sometimes we have very small numbers, like this example here. So here's the decimal in this problem, and all of these zeros come before the first non-zero digit. Now, those zeros are called leading zeros, the ones that start out the number. Now, it's the same idea that we have to get the number into scientific notation. So you take the decimal and you go 1, 2, 3, 4, 5, 6. So I want to move it till you have a digit and then the decimal. So then my coefficient is right here. It's 3.18. I moved the decimal 6 times, so it's 10 to the negative 6. Small numbers always have, and small numbers I mean less than 1, they always have negative exponents because if you're less than 1, you're dividing by 10. So when I move the decimal place 6 times, it's like I'm dividing by 10 6 times. So we move the decimal either to the left if we have a large number, or right if we have a small number, to put our number from standard notation into exponential notation. Now if you look down here, it says in the coefficient, the decimal is always placed right after the first non-zero digit, or what I call the second place. So I gave an example. So here's a number right here. It's 25,800. So we would move the decimal to correctly. We'd go 1, 2, 3, 4. So it'd have one digit, the decimal, and then the 5/8. So we have 2.58 times 10 to the 4th. This answer is correct. Now if I moved it over, let me erase how I did it here. Okay. So if I move it over 1, 2, 3, I have 25.8 times 10 to the 3, which mathematically may come out to be the correct number, but this is not how we write it in scientific notation. Notice the difference. The decimal is in the place directly after the first non-zero digit. So let's look. What if I'm going to write two numbers and I would like you to write those in the correct exponential notation or scientific notation, and then I'm going to write two other numbers in scientific notation. And I would like you to write these numbers, into standard notation. So on the first one, write these in exponential notation, and the second one, write those in standard notation. You can pause the video because I'm going to do the answers right now. So to write a number in the first part, to write it into scientific notation, take where your decimal is. This is a large number. We'll move it 1, 2, 3. So it would be 6.8 times 10 to the 3rd. And then this one we'd go 1, 2, 3. This would be 4.169 times 10 to the negative 3. Now when talking about significant figures, if I had these numbers as they are written, this one would have 2 significant figures as it's written, and this one would have 4 significant figures as it's written, because you just look at the numbers in the coefficient. So let me just make a little side note here as I'm trying to maybe put some ideas together for you. Let's say on this one, the question, you only needed 2 significant figures, not 4. So you got this on your calculator and now you need 2. So I would only want the 4 and the 1, so I would be dropping off this 6. So I would rewrite it 4.2 times 10 to the negative 3. And that would be the same number that we just had, but with 2 significant figures. So I guess what I want to emphasize is that the coefficient is what tells us how many significant figures there are. We don't have to move the decimal or anything, we just look at the coefficient. All right, so in the second part, I wrote 2 numbers in scientific notation, and I wanted you to write them in standard notation. So this is a negative 2, and I know that a negative exponent goes with small numbers, so I need to move, if I have the coefficient, I need to move the decimal 2 places to the left, 1, 2. So that would be 0.0242. Now, this 0 here is just a placeholder, and it's a convention that I learned when I was writing decimals in the ones place when I have numbers less than 1 to put a 0. That is not required. You could have just said 0.0242. It's just how I learned to write numbers less than 1. Now this number, the 7.4, here's a 6, so this is a positive exponent. It's a large number. So if I take my coefficient and I'm going to move my decimal place to the right 6 times. 1, 2, 3, 4, 5, 6. These would all have zeros in their spots. So it would be 7, 4, 1, 2, 3, 4, 5 zeros. And that's what that number would equal. Now, one thing I haven't gone into in this video, and I'd like you to reach out to me, it's kind of hard on this particular video to do this, but you need to be able to use your calculators and entering in exponential or scientific notation. So what I'm going to do on the next slide is I'm going to write a sample problem. And I want you to try to do it in your, enter it into your calculator. And I'm trying to find one that I know people could mess up on if they're not entering it incorrectly. I mean, if they're not entering it correctly, excuse me. Sometimes I get tired. Okay. So I want you to enter this into your calculator, and you can pause it now and see how you get, if you get the answer. I will will enter this into your calculator. If you get an incorrect answer, I want you to come talk to me. My calculator gave this to me in it gave me in standard notation. So I get 171428.57. It keeps going. So in scientific notation, I'd move it 1, 2, 3, 4, 5. So I would get 1.7. Now I'm going to keep my coefficient with just 2 digits because this one has 2 sig figs and this one has 2 sig figs. Because remember, I just look at the coefficient. So I'm just going to keep the 1 and the 7. I'm going to say times 10 to the 1, 2, 3, 4 times 10 to the positive 5. So this is the answer that I would record. Now this number here is how my calculator showed it to me. Your calculator, if it was in exponential notation, if it gave you the answer, it would still have all, and usually it says like an E. Oftentimes it says an E, which means times 10, and to the 5, and with a 5 behind it. One thing, just if you're recalling, if you when you're dividing exponents, you would subtract them. So in this example, it would be 3 minus a negative 2, and that's how I end up with positive 5. When you multiply exponents, if you recall, you add them. Now, we don't really have to do this because our calculators do it for us, but sometimes it's a good check for you if you're uncertain or you're just trying to see if your answer makes sense. So if you did not get the right answer to this, then I would like to see how you're entering it into your calculator and help you learn the correct way to enter exponential numbers into your calculator.